So we are in the last question. Okay, I'll show you the question. Okay, can you write this question? Form the partial differential equation by eliminating the function f from. Okay, don't see the answers. Okay, you try yourself. Okay. So this is the questions. Form the partial differential equation by eliminating the function f of x plus y plus z is equal to function of x square plus y square plus z square. So if please have some try yourself. Okay, so these are very not much things, but very interesting one for you to get the answers. Anyway, if you want, I'll give you the answer anyway for this question. It is little bit interesting one. You can try. The answer will be like this way. So what you have to do is you have to take the differential equation, okay, with respect to x, y, and divide it. Okay, divide the equation 1 by 2 or something. Okay, you will get like this 1 plus, this is the final answer. Okay, sorry, final answer will be x minus y is equal to, see whether you get that answer. Okay, x minus y is equal to z minus x cube plus y minus z p. This is our equation. So you do all the simplification to come out here. So the technique is you divide the equation 1 by 2 or something. Okay, or 2 by 3, anything. Okay, by dividing and cross producting, you can have this answer. Very easy, not that much harder. Okay, see whether you can derive this equation. Also, I have assigned some of the examples in the homework quiz as well. Also in the homework quiz, there's one more question about pi u comma v, like question. On that sense, you use the now derived equations there. No, the same way you have to find the answer. Okay, so you have to find dabba pi over dabba u, like that. Okay, the same method. If you follow it again, you will get the answer. Okay. Okay. So that's all about the chapter number 1. So what we have studied in our chapter 1. So this will be one of your continuous assessment fully. Okay. So first of all, I have divided your chapters in this way. Okay. So I have ended here. So you can see my chapter 1 has introduction part there, basic definition, classification of solution, formation of partial differential equation, all these things. Okay. So now we're gonna go to the chapter number 2 anyway. Okay. So also I think I need to add some this classification. Okay. So that what I wanted to finish today. Okay. So we can finish around 45 something. So before that, before finishing the chapter number 2, sorry, chapter number 1, I'll give you some this also. Okay. Classification of first order. Okay. So I think no need. Okay. So that's all our chapter 1. I'll give you the chapter 2 notes. I'll display you here, but I will send you the notes with our next lecture. Okay. So let me share it. I'm not yet finished the typing, so that's why I didn't send you. Okay. So anyway, we can start up and end our session today. Then we can follow up lectures. We can have the notes. Okay. So put the heading as a chapter number 2. So we almost finished our chapter number 1. Not almost, we have finished our chapter number 1. So we will have our continuous assessment on that full chapter. Okay, one of our continuous assessment. So get ready for that. Take all your notes, take all the things, and also I will send you the homework number 1 for that, and do that and see whether if you don't understand anything or any problem, you can ask me. Okay, you can send a message or you can send through the group message. Okay, not a private message. If you are asking anything around regarding the lectures or anything, you just use the group message. Okay, also you can ask in between our lectures also. So that's that. So let's continue our chapter number 2. For that, so put our first heading. So classification of first order partial differential equation. So we know how the first order will look like, no? So we'll have some independent variable, we have some dependent variable, we may have p comma q. This is what we thought this is our first order partial differential equation format. Okay, so let's see what are the types for first order available. Okay, so you can write down the notes when I'm scrolling. Okay, so these are the classification we're gonna see here. But here I just type something only, but in between I will give you some extra notes as well. So you have to, don't copy after this one to this one. I'm going to give you some more extra things in between also. So wait for me. Okay. So first of all, you write down, put the heading. Okay. First of all, let me introduce the things. Okay. So this is what we're going to. Okay. So the classification of first order partial differential equation into semi-linear, quasi-linear, and non-linear with example. Okay. So even though the first order, we're gonna divide it into 3. First one is called semi-linear or semi-linear. Okay. Second one, quasi-linear. Linear has some differences in between, small differences. Okay. So linear, we know what is linear, no? What do you mean by linear PDE? You already have the definition. What do you think? What is a linear PDE means? Linear and non-linear. What is that? We have the power 1, isn't it? Degree is 1, and we don't have any multiplicative like this. We can't have, no? Z as well, P. Sorry. Okay, Z and P. Similarly, so many things are there. Okay, so give me 1 second. Hello, sir. Oh, sir, lecture again 11:45. Okay, online lecture. Okay, so ZP. Okay, so we can't have this one as our linear, no? Did you understand? So we have some definition, no? You go back and see what is the definition of linear. Okay. Similarly, non-linear means if it is not the definition of linear, we call it as a non-linear. Okay. This linear also we're gonna divide in two different ways, which is semi-linear and quasi-linear. Okay. We see what it is. Okay. Okay. Now, so write down these things. Okay. First of all, semi-linear equation. Put the heading semi-linear equation. I think first of all I need to give you the idea of linear. So we know linear equations have in the first order we have like this: x, y, z, p, comma q is equal to 0. Okay, it's known as linear. This is linear equation. Okay, if it is linear in p, q, and z, okay. So it will be the equation of this may be look like this. Let's say P is a function of x comma y of, sorry, this is capital P, okay? Capital P of P plus Q of x comma y of Q is equal to R is x comma y of Z plus S is x comma y. So don't confuse about small p, q, r, s, t. That is different case. No, this is da by z or da by x. These two are first order. These three are second order. I'm not talking about this one. See here, I'm just taking p and q only. But I'm going to take capital. This is our notation the books are using. That's why I'm following that one also. Okay, I'll show you in the whiteboard, so it will be easy for you. Okay, give me a second. Okay, what they are saying is the linear equation. Okay, linear equation will be in the form of f of x, y, z, p, q is equal to 0. So actually it will look like this. Some function of x comma y, because these two are only our independent variable. For example, this one will be x square plus y square, something like that, a function of x. So I am using capital P of P, small p, okay, plus capital Q of x comma y, any function of x, y of Q, which is equal to R of x comma y of z. So z also available now. It should be there somewhere. So it's equal to any function which doesn't have this derivative, something, let's say only the function. For example, let me say this kind of equation, okay, x square y squared of p plus x cube minus 2q is equal to x squared z plus y squared minus 3, something like this. See, I have some capital P, which is a function of xy of p. This is something q. This is my z. Sorry, this is my capital R. This is my s. Only the function of this one. So did you understand? So this kind of equation we called as a linear. See, all the powers are 1, 1, 1, 1. There's no multiplication of x, sorry, and z and derivative are there. Okay. So this is a 2, okay? 2, not a z. So this kind of equation we called as a linear equation. So you can write as a note first of all, before going to the semi-linear. Okay. So now I'll go back to the notes, okay? Okay, yeah, chapter number 2. So now write the semi-linear, okay? Semi-linear equation. Now the definition gives the first order partial differential equation of this one. This is the idea of first order equation. Is known as the semi-linear equation if it is, please write down this, if it is linear in a comma b and the coefficient of a comma b are function of x and y only. Okay, I will tell you what it is. Please write down first of all. First order p, sorry, this is not a b, I think. Okay, anyway, write down. First order PDE of x, y, z, p comma k is known as the semi-linear equation. If it is linear, it's not a, okay? Write down this as a p, small p and q. It's a linear p and q, and the coefficient of wherever it is a and b, you write down pq, okay? A first order partial difference, this is p now. Sorry, there's a wrong in this one, so I'll write it, okay? Wait for me. Okay. Semi-linear, so we have seen the linear, now semi-linear. Semi-linear means a first order PDE of f of x, y, z, p comma q is equal to 0. This is small p, okay? Write nicely. capital P you have to write this way. Okay, give me a second. Okay. Lecture la irken na konjam 5 minutes thaanga. Oh, seri na lecture la irken. Lecture mudiyana varam konjam. Okay. Okay, sorry. Okay, sorry about that. Okay, so capital P, small q, and small p we have to write like this way. Okay. Now the first order PDE f of xyz p comma q is equal to 0 is known as semi-linear equation if it is linear in P and Q, small p and q, and the coefficient of P and Q. Okay, the coefficient means, no, before the P and Q there is something, maybe element or functions. Okay, P and Q are here functions of x and y only. Okay, so you have to keep it in your mind. We are dividing the linear only, semi-linear and quasi-linear. So it should be obey the procedure of linear already. Then there's a small difference. Okay, with these two. It is also linear, it is also linear, but a small differences. Okay, so the first order PDE, this one is known as a semi-linear equation if it is linear in P and Q, and the coefficient of P and Q are the functions of x and y only. Okay, we can see the difference between the quasi also. Okay, so write down the equation should be in the form. Okay, write down, that is the equation is of the form like this: capital P x comma y of P in plus capital Q x comma y cube, which is equal to capital R x y z. Okay, so this is small difference from the what I have written for the linear equation. Okay, so capital P, capital Q, there we have R x y z and x s x y. No, here we have all the other terms will be x y z terms will be in the other side. Okay, so only P and Q have the functions of x and y terms. Okay, this is what they say semi-linear. Okay, likewise. Okay, let me finish the lecture writing these all and finish up our lecture. Okay, please write down with me also. Don't wait for me to finish. Okay, quasi-linear equation means, so these are the classification of linear PD. Classification of first order PD we are analyzing. Okay, quasi-linear means a first order equation f of x, y, z, p, q, which is equal to 0 is known as quasi-linear equation if it is linear, already it is a linear, okay, in P and Q. A first order equation is quasi-linear if it is linear in P and Q. So what's the idea? Okay, how it's look like is, that is, the equation is of form like this: capital F x y z p. See, in this equation itself you can have the set inside. It is a small p. Okay, plus q also have the function of x y z of q, which is equal to r of x y z. There's a small difference between the semi-linear and linear. Okay, everything are same, already a linear, but it has order power 1, 1, 1. It is okay. But the P can have the function only, this function only can have P and Q only. Okay. There is no Z functions, like that. Okay. So please write down this. Okay. So shall I write? Okay, I'll write quickly. Okay. Other one is so we have linear. In that we have seen what is linear, what is semi-linear, what is quasi-linear. This is what you have to be clearly about. Okay. I'll give you some example also. You don't worry. Next one is our non-linear. So let's see the definition of non-linear. So write down a first order, same thing. Okay. First order equation f of x, y, z, p, comma, q itself a first order equation is known as linear if it does not come under u, okay, under above three types. So with the this and this and this, if doesn't obey any condition, we called as a non-linear. That's what it say. If it does not come under above three type, we called as a non-linear equation. Okay. So we can continue from next lecture, hopefully. Okay, next Friday. So I'll finish from here. Okay. So you can please go through again everything, and I will send you the homework also. So get ready for everything. Also, chapter 1 we have fully finished. So get ready, like as a continuous assessment. You can search more things using the Google or YouTube. All these topics you can search and learn and be ready. When you are coming, you have to write all the exam at once. No, you have to write all the 4, 3 continuous assessment in one day. So you have to ready. So use all your times, very well. Okay. Okay. I'll finish now here. Thank you very much, everyone. Okay. Take care. Bye. Mm-hmm.